Hello guys, I'm the machinist man, and in this video we will start machining the mold we discussed in the previous video with SolidCam software. So at first we need to click on the SolidCam icon at the right, and then by pushing the new button we will be able to select between the milling, turning, mill turn and others. So we select the milling here, and then we have to select the way that we are gonna save the SolidCam file. We can choose between the external and internal. In the case of using external one, we will have a single zip file at end, which includes the whole detail of the CAM project. But by selecting the internal one, the whole file, I mean the CAD and CAM, will be merged in a single file. And we prefer using the external file because in the case of any crash, we will be able to restore the whole details back. So my preference is external, and also I select the directory of the model for my CAM project, and at the end I select the metric units to work on it. So click on the green checkbox. So, so we wait here to be loaded. And here in first, you know, in first location, we have to select the post processor we are gonna work on it. Upon installation of the SolidCam software, you will be able to select between different post processors depend on the machine you have. But I select Gmuli 3X because that's the default post processor upon installation. And then I need to define the coordinate system of my machining. Most of the time I prefer selecting the center of the block for machining, so I will select that one, but you can select wherever you want based on your project. So in here there is different ways for defining the coordinate system, and maybe the easiest one is select face. And by selecting the face, the SolidCam will suggest you know some points that are more more probably to be selected by you. So you can see that after clicking on the face, there is few points on the block that can be selected for the center of coordinate system. So I select the middle one. Actually I have to select face and then select pick origin button, and then I can select every point that want, and you can see that the X direction and the Y direction and also the Z directions are correct. But if the directions are not correct, you can flip around each axis you want to define it, and you know find it in the way that you want. So you can flip around each direction that you want. So with me, yeah, that's right. And also in some complicated situation, you can modify you know the coordinate system by rotating that around the axis the amount that you want. For example, I rotate it for 30 degree, and you can see that it changes degree, and it lets us to define whatever we want. And also in this case we can change the position of it in this direction. For example, I want to change it 10 millimeter in the X direction, and you can see that it just you know shifted to the new location, and 25 millimeter in this direction. And this enables us to satisfy the whole condition of our project, because it gives us a lot of power to be the master of defining coordinate system in the software. And that's enough. Actually, by these items you can define the coordinate system with different ways. For example, by defining item, you can select the origin, X direction and Y direction, and the coordinate system will be fully defined. And the others are some different ways for defining coordinate system. But as I mentioned, this is the easiest way, and I prefer this definition type in at least 95% of all cases. So let me define the coordinate system again. I have to select pick origin first, so I will try it. Pick origin, and I select the middle center point here. That's good. Let me go to the next page. And here you can define the level of the machining of the part. You can define the start level of the machining, the clearance level, that is really important, the upper level, lower level, that is defined based on the part you have here. And you can define the other levels that are a lot more useful in 4 and 5 axis machining. So we keep that to the default values. And you can see that the Mach 1 first position is defined, and you can define a lot more, and you can define another coordinate system for the case of 4 and 5 axis machining. But here we do not need it, so we click on the green checkbox here. And then we need to define the stock material that we are going to machine. So we click on the stock, and here we also do have a lot of ways for defining the stock material. In the case of using the box, we will define a box around the part that is relative to the model. So here, by selecting the model, these green lines are gonna emerge, that are the definition of the box, that is the rough stock here. And here we can expand it to the amount that we want. For example, we can put 5 millimeter extra material at top that have to be machined at first. And also we can define 5 millimeter at the bottom, or 20 millimeter at the bottom, that enables us to to do some extra works at the end. So because of the fact that we do not wanna remove extra material here, we put these values to 0, and suppose that the block is grinded to the size that we need. So we click So we define the zero for all these items. It should be noted that by clicking on this button, this line is gonna be turned to a sketch. So that would be helpful during the operations. So we click on it and we can also create a 3D model. I do not prefer to click on it because this sketch is enough. So we click on the green button here, and after it we have to define the target. Actually the target here is the main file that we have, so we click on it to be defined, and that's a good you know attractive color. And that's done. And we should we should pay attention to this, that the model is defined with facet tolerance here, that is 0.01 millimeter. Actually the model is formed with a lot with too many triangles here. So this is actually the tolerance of those triangles. So we can we can keep working on it with a not high tolerance, because as we increase the tolerance we have to pay a lot more time, and also we have to wait for the machine to calculate the whole thing. So we click on the default value because maybe that's better for beginners. And in the finishing operations we can tighten that tolerance, because we need you know a more precise G code. So but here we don't have to make that tight. And that's done. We don't need to click on recognition, because up until now I haven't used it. And here I'm machining data. Actually, if you wanna use some options like I'm machining 2D and 3D, you have to fill these items. But here, because of the fact that we are not gonna use it, we do not touch these items. But in the next videos, in the case of defining the eye machining, we will explain these items fully defined, in order to not to annoy viewers, because here we do not need these items at all. So I click the green button, and guys, that's done. Up until here we have completed definition of the cam part of the SolidCam project. So in the first in the next step we will define the milling operations that we need for machining from rough stock to achieve the target. So because we do not want to you know increase the length of the video, we roll up this video here, and in the next video we will start generating the toolpaths for different boundaries here. So thank you for allocating the time here, guys, and see you in the next video.